G'day, welcome to Matt's Workshop. This is episode 4 for the CNC laser rotary attachments, and in this episode I'm going to look at the pros and cons of the chuck versus the wheels, also known as the roller rotary. With the chuck rotary to start with, the chuck rotary, it's got a 80mm chuck with the teeth that can be changed for inward or outward gripping jaws there, and we have a centerpiece here for aligning the back end of the workpiece. So to start with, the setup of the chuck rotary was quite simple. Had a very basic sort of setup with a 2:1 ratio gear, which was very easy to calculate the steps per rotation. So the good thing with that is when we're entering data in the software, we don't have to keep changing the steps per rotation, because its steps per rotation compared to the object diameter and the chuck diameter is always 1:1. So all we need to do in the software is change the diameter of the workpiece that we're working with. If we compare that to the roller rotary, the roller rotary has a gear ratio on this one calculated at 1.5:1. So that's not so hard, but we have the wheel ratio and the object diameter, which we then also need to find out the ratio between the wheel and the object for each different piece that we're using. Constantly doing calculations if you're changing different diametered objects. If you are just doing the production of the same item every time, then obviously you wouldn't need to change that. But yeah, if you are doing a variety of different objects, different diameters, the calculations do need to be changed for each diameter. When it comes to holding material into the chuck rotary, got the inward and outward gripping teeth. But the end piece has just got the point on there, so I find that we do need to develop some sort of holding mechanism for fragile items or large items, like I demonstrated in that video. So this is the one that I demonstrated on that video, where you can attach different sized discs onto the chuck, lock that into place, and then use this on the tail end and wheel it up and clamp it into place. So with that, it does make it easy to use. If we compare that to the roller rotary, we can put on here pretty much any diametered object so long as it fits underneath our laser head. The only thing is that there's no mechanism to hold that down. We're relying on the rubber that's on the wheels to cause friction to turn that item that we're engraving around. So that can cause slippage, which can then also cause inaccuracy in our engraving. With our chuck rotary axis, we're limited by the distance or the height of the object that we can engrave on. So with the pad that I've got in place here, we're looking at approximately maximum length of about 210mm. And even with this out, it only gains us about another 10mm. So for example, the bottle that we were engraving on the rotary, the roller rotary, it won't fit in here with that pad in place. The only way that we can fit that in place would be to remove it and use the jaws to clamp down on the glass. The problem with that is that we risk damaging the workpiece and possibly cracking it. Now the other thing that we need to note is that we can only engrave on the flat sections effectively. You can engrave on sloped areas, but then you've got to remember that your laser will go out of focus in that area. So if you wanted to engrave on this section of the glass here, this part would need to be level for it to engrave quite nicely. So that's quite a long way out for it to be propped up. And just as an example, if I was to raise the back of the rotary up to get it level, we'd be looking at there. And then unfortunately there'd be no room between the bottle and the laser head to focus effectively on most units. However, with the wheel rotary attachment, the other thing that you can do is loosen the screws at the back and adjust the rear wheels, or the wheels on this end that are not attached to the motor. So you could dial it up, but it still would not be level. This does not raise up high enough. So when we're using a chuck rotary, say for example we're doing something small like this, something small in diameter, and we want to engrave on it. I'm only using this as an example, but we always need to make sure that our laser head does not knock into the side, so you have the risk of the laser head hitting the unit. With the wheel rotary attachment, the unit that you're engraving is always above the wheels and above the rotary, so there's no chance that the laser head is going to hit any object on it. So that is one benefit of the wheel rotary. So with the chuck rotary axis, as you can see, we could clamp that in on the jaws or hold it in place with our soft workpiece so that it doesn't damage it. But then it is always running on its central axis. You can't actually adjust for the slope of the glass unless you were to slightly move the back of the rotary attachment up until this was level. So this glass has a slight slope in it, so you would have to prop the back up until the top of the glass was level with the laser head so that it didn't go out of focus. With the wheel attachment, the glass is always on the top, and you can lower and heighten the rotary wheels at the front end of the glass until it is level, which is a good option for engraving on sloped objects. So even with this attachment lowered all the way down, this is still not quite level. We're out by a few millimeters there. So what you would need to do is put a rubber band around there and raise it up off those back rollers. And by doing so, you then need to calculate the outside diameter of the rubber band so that you could work out your steps per rotation effectively for that sized object. So if we raise the back of this rotary up, what we could actually do is get that glass level on that. So the only thing there is that the heaviest part of the glass is now up higher and not resting on the drive wheels. So that would mean that we could get some slippage coming from the light end of the glass. So it's just something to bear in mind, is that yes, you can get it, and you just need to make sure that when it rotates, it's going to rotate without slipping. So as I mentioned, the chuck rotary has limitations to the length of the object that you can put in there, whereas the roller rotary, you can move the wheels quite a long way out and be able to fit something like this long rolling pin on there if you wanted to engrave on that. So the maximum length for this particular unit, all the way out, between the wheels we can have approximately 300 millimeters. So it's quite a big distance that this can move out. Another benefit of the roller rotary is that if you wanted to change your pieces, it's very easy to do just by picking it up and taking it off. And with the chuck rotary, we're holding things in place with jaws. So we've got inward facing and outward facing jaws that need to be removed and reinstalled using the chuck key there. Now the other thing is we're looking at the height between the objects. So what I'm going to do is show you inside the machine. Okay, so I've got the chuck rotary axis inside the machine, and just to give you an idea, we have the laser head positioned up here, and I can raise that laser tube all the way to the top. It gives us extra height for engraving. For demonstration purposes, I've put in this jar that we engraved the other day on the rotary attachment. So what I wanted to show you here is that if we have a look at our focus height, this is as low as the Z will go, the bed will go, and the honeycomb bed is already been removed. So if we needed to focus this, we've got here our focusing gauge as well as a ruler to the top of a 127mm jar. Gives us approximately 14 to 15 millimeters. So safely you could say that you could probably engrave something to a maximum diameter of 140 millimeters. And that would all depend on how far you could lower the bed on your machine. So you've got a jar that's 140 millimeters, but you want to do something bigger with the chuck rotary axis. Here's a little tip that you could use. You could tilt. Ensuring that this is nice and secure, which it's quite solid and it's not moving around. So by just rotating it onto that side angle, the rotary will still function exactly the same. It's not going to upset a stepper driver being rotated 90 degrees. So now if we get our focus gauge and our ruler and measure the difference, we have our ruler there, top of the workpiece. We have gained approximately 50 millimeters. So just by rotating it, we can actually go up to something quite large. And now the only limitation would be the workpiece gap between the chuck roller axis's rails and the centerpiece. So you'd need to make sure that that was clear. If you had it in this position, then you'd also, after focus, make sure that it's not going to hit into any part of the chuck rotary axis. Okay, so I've got a roller rotary axis in place. And if I want to use the same jar that I used on the chuck rotary axis, which is 127 millimeters in diameter, and I pop that onto the roller, as you can see straight away, there's no way that I could engrave on something that large. So we're limited to little objects. As an example, I'll put this bottle that we engraved last time on there. We'll move the laser head over it. Now that bottle was 77 millimeters in diameter, and even that is struggling just to focus. So it is at the focus height, but roughly 77-78 millimeters in diameter is the maximum diameter that you can engrave on this one. And the other limitation, as you would have seen in the video that I did on the wheel rotary axis, is there's no way of holding it to the rotating surface. It just sits on the top, which means that if we have jerky movements, the actual workpiece can move around. And then make sure that the return speed is not too fast. That would make it dislodge or break. So I hope you've enjoyed this rotary axis series that I've put together. I've tried to be as comprehensive as possible. So when it comes to choosing between which rotary axis you want to use on your machine, just bear in mind some of those limitations, whether it be the diameters of the workpiece, the length of the workpiece, and the methods of holding it in place. The roller rotary can slip around a little bit. It is good for heavier objects, not so good for light objects. The chuck rotary axis is very good for those lighter objects. And you just need to also always make sure that the laser head is not going to come in contact with any part of the chuck rotary axis when you're operating it. And that's obviously not an issue with the roller rotary. I think when it comes down to it, the chuck rotary axis is a lot easier for calculating your steps per revolution and things like that. And you only then need to calculate the diameter of your workpiece. But the roller rotary axis does give you the ease of replacing objects very quickly. If you're doing a production pieces and they're actually the right weight and they're going to turn effectively, then the roller rotary is the way to go. The other way is to use the friction pads. These are quite handy. You could probably look at modifying this so that it didn't have a point but just a flat piece. That would give you a little bit of extra distance that you could use. But and then also make it more secure when you're using the chuck rotary axis. With the roller rotary, one of the benefits was that you could raise and lower the height of the second set of wheels so that you could get your workpiece level. I hope you've enjoyed the videos. If you do have any questions, you can leave some comments below or even on the community page of my YouTube channel. You can also visit my website, which is in the description below. The link is there, and from that website you can use the Facebook messaging to send me a message, or the contact us page if that is not available. I'll also leave a link to Cloudray Laser's website below where you can find these two rotary attachments, and if you haven't already, press the subscribe button and the notification bell to be notified when I release new videos. If you like the video, give it a thumbs up, and until next time, take care. Cheers.